The last section in our chapter on linear equations has to do with linear inequalities. An equation has an equal sign. An inequality has a greater than, less than, greater than or equal to, less than or equal to sign. So that's what we're going to be looking at in this section. So it says graphing inequalities on a number line. Example 1 says to graph x is greater than or equal to -1. Well, the first thing you need to know has to do with these symbols. So let me group them. Notice these two do not have the line underneath them, meaning it's not or equal to, it's just greater than, less than. Those we show on a number line with an open circle. These have the or equal to line under them. In other words, they take more ink when you draw them. So the circle on the number line takes more ink and it is filled in, which is an easy way to remember it. So what I want to do is I want to locate my key number here, which is -1, and on our number line it's not labeled, but if this is my 0, we're going to label this as our -1. Since it is greater than or equal to, I'm going to put a solid dot on the -1 because that is included in the answer. Now, rather than it being just -1, it says it's everything greater than or equal to -1. All you have to do is think of that sign, I'm going to use a different color here to show you this, as the end of an arrow, and that arrow is pointing to the right. So we want to shade everything to the right, and I only made my line wiggly so you could see it on top of that original number line there. So we're talking about -1 and everything that is greater, and that's how you show the answer. Let's look at the next one. It's similar but actually very different. It says -1 is greater than x. One of the things we have to learn about inequalities is when you are solving them, before you graph them, it matters which side of the symbol, the equality or inequality symbol, the variable comes on. So down at the bottom of your notes, we're going to drop down to the bottom for just a second and then we'll come back up. It says there are 2 times when flipping the inequality sign is necessary. They are, and here is the first one, when the variable ends up on the right instead of the left. With an equal sign, it doesn't matter. You could have 4 equals x or x equals 4. Doesn't matter. Here it matters. So when the variable ends up on the right, what you have to do is flip the whole thing. The whole thing. And I'm going to show you what I mean by that by going back to our example in number 2. It says -1 is greater than x. My variable is on the right. So I'm going to pick this up and turn the whole thing around so that it starts with the x, and now my sign has to flip, is less than -1. You have to do that in order to be able to tell which way to put your arrow on your number line when you put your solution. So you turn around the entire thing. So it's going this direction and the sign has been flipped. So x is less than -1. My key number is still -1. This time there is no or equal sign, so I don't need a filled in circle. I need an open circle on my -1. But look, if you, again, here's my symbol. If I make that into an arrow, look what direction it's pointing. If that's the end of my arrow, it's pointing this way. So we show it like that. Example 3, this one is also different because my x is in the middle. This is called a compound inequality, and I actually think this is the easiest one because the inequality looks exactly like what goes on the number line. Look where the x is. It's between the -4 and the 2. So let's show that. -1, 2, 3, here's -4. Here is +2. My x is in between. So it's everything in between. Now we have to look at what to do with the endpoints. This symbol does not have an or equal by the -4, so it's an open circle. This one does have an or equal, so it is a closed circle, and we are talking about everything in between. That's what x is equal to. -4 up to 2, including 2, not including -4, everything in between. So it looks just like the sentence. If I write the inequality sentence underneath, you can see there's the -4, there's the 2, x is in the middle. All right, let's step back a minute and look at what are the steps for solving an equation. So if we had an equation, x plus 4 equals -6, the way we would solve that is to subtract a 4 from both sides, and we would get x equals -10. Well, here in example 4, I have the same thing, but rather than an equal sign, I have a less than or equal sign. The steps, however, work the same way. So we're going to subtract a 4 because our goal is still to get the x isolated. That zeroes out. X, keep your sign, is less than or equal to -10. So compare these two. I still have an x on the left. I still have a -10 on the right. The only difference is the equality is just, it's equal to -10. And the inequality is it's equal to or less than -10. So my key number is still -10. Well, I don't want to put my 0, this one isn't labeled. I don't want to put my 0 here because if I do, I'm not going to have enough hash marks to go across the little lines. So I can put it wherever I want. And since I'm only talking about negative numbers, I'm going to put my 0 right here. And then this becomes -1, -2, 3, 4, 5, 6, 7, 8, 9, and -10 is right here. It's a closed circle because it has an or equal to, and we are talking about everything that goes that direction down. And the reason is my symbol goes that way, so if it was an arrow, it would be pointing that direction. So solving an inequality is just like solving an equation as far as your steps go. So let's look at what are the steps for solving -2x equals -4. Well, here my x has been multiplied by -2, so we would divide both sides by -2, and we would get x equals a negative divided by a negative is a positive. We would get x equals 2 as our solution. We do the same thing here. We're going to divide both sides by -2, but, and this is important, this is the second time when you have to flip the sign, and that is when you divide or multiply, and it's usually divide, okay, but just know it can be multiplied, by a negative, I'm going to abbreviate, number. When you multiply or divide by a negative number, you have to flip the sign. So I am dividing by a negative. That makes a 1. Oops, I did not mean to put an equal sign there, so hold on. A negative divided by a negative is a positive. My sign was this, so now let me see if I can do this. I have to turn it around that way. There, I kind of made that a little bit better. So the sign flips when you divide by a negative, and I have x is greater than or equal to 2. So if I go over here and I label this 0, this would be 2. I have a closed circle on the 2, and my arrow is pointing to the right, so my line points to the right. So as a quick review, you are going to flip when the variable ends up on the right, you flip the whole thing. When you divide or multiply by a negative, let's finish this statement. I'm making a lot of noise here. You just flip the sign. So when the variable's on the right, you flip the whole thing. But if you are dividing by a negative or multiplying by a negative, you are just going to flip the sign. So let's look at a couple more of these where there's more solving that has to be done. So on the next page, we have solve 2x is less than negative 4. To solve that, we would divide by 2. Now, the reason I put this one on here is to show you I am dividing into a negative. That's okay. I am not dividing by a negative. Therefore, I don't flip the sign. A negative divided by a positive is a negative. My key number is negative 2, so if this is 0, there's negative 2. It is an open circle, and my arrow is pointing to the left. So it goes that way. Now, just as a quick sort of reminder of the steps for solving an equation, it is to get rid of fractions, distribute, combine like terms, get variables equal to numbers, and then divide. It's the same thing with inequalities. So if I had this equation, my steps would be to subtract the 7, negative 4x, equals negative 16, and then divide by negative 4. And I would get x equals 4, and that would be my answer. So when we do it as an inequality, we use the same steps. We subtract the 7, negative 4x, that zeroes out, is greater than or equal to negative 16. Now I'm going to divide by negative 4. Think I'm dividing by a negative. That makes an x. I have to flip my sign because I divided by a negative. A negative divided by negative is a positive. So my key number, just like this one, is still 4. So if this, let's call this 0. 1, 2, 3, 4. My key number is 4. It's going to be a solid dot because there's an or equal, but my arrow now is pointing to the left. So I make it go to the left, and it's everything that's lower than 4. Let's do one with a few more steps. Number 8 says to solve this equation. So if you notice, before I can combine like terms or divide, I have to distribute. So I've got negative 5x plus 7 is less than, distribute that 2x minus 6. There's no like terms on the left, no like terms on the right, so I now need to get my variables equal to my numbers. I am going to choose to add a 5x to both sides. You could have also subtracted a 2x. It doesn't matter. I get 7 is less than 7x minus 6. Now that the variables are on the right, the numbers have to go to the left. Let's move this up. That would give me 13 is less than 7x. I'm now going to divide by 7. And 13/7 doesn't divide evenly, so I'm going to leave this as 13/7, but a couple things have to happen. My variable ended up on the right, so I have to turn the whole thing around and write x is greater than 13/7. Now, how do we put that on the number line? I have to show 13/7. This is how I think of it. I think, well, if it was 14/7, it would be equal to 2. So 13/7 must be just a little bit less than 2. So if this is 0, and this is 1, and this is 2, I know that I want an open circle that's a little bit less than 2, and my arrow is pointing to the right. Now I'm going to show you another way you could have done it. I'm going to put it up here where we have space. Okay? I could have called this 0, this 1/7, 2/7, 3/7, all the way, and I didn't make mine long enough, all the way up to 13/7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I still don't have it long enough. 13. I could have done it like that. That's not a real efficient way to do it. It's better to understand that this is very close to 2. And show it on your number line that way. But this would not have been wrong as long as you had labeled it correctly and shown me what you were doing. Let's look at our last one. It has a lot more steps to it. Here I have a distributive property. So 2x minus 6, neighborhood kid, is less than or equal to, distribute again, 3x plus 6, neighborhood kid, minus 18. Our next step is to combine like terms. So 2x, a negative 6 and a negative 5 is a negative 11. 3x, positive 6 take away 18 is negative 12. Now I want to get my variables on the same side, so I'm going to subtract my 2x. 3x minus 2x is 1x. I am now going to add a 12, and I get, I'm going to write it up here so you can see it, a negative 11 and a positive 12 is a 1, is less than or equal to x, but we know we can't use our answer like that. The x is on the right. Turn the whole thing around. X is greater than or equal to 1. I flipped my sign. I flipped the entire thing. So if I go over here and I make this 0, here is 1. It is a solid dot because of the or equal, and it's going to the right. On the next page, there are some on your own problems. There are 5 of them. You need to try those, and if you have questions, bring those questions to class after you have tried these and to see what you can do on your own.